Right, let's see what it means now to create a bit mask and to read individual bit values. Right. We often want to know the state of a bit. In order to read a single bit or multiple bits, we need to know the bit size of the data or the hardware register we're trying to access. Well, how many bits is it? We need to create a bit mask. That's a binary pattern that we're going to use to isolate the bit or bits to be read. And then we're going to use a bitwise operator along with the bit mask, that binary pattern, to actually read that bit state. So suppose we want to use, or we want to read the state of bit position B0. We have this binary number. These X's here represent the fact that we don't care what's stored in bit positions B7 through B1. Where I have the question mark means that's the bit I want to read. I want to query that and see whether that value is a 0 or a 1. We want to keep in mind the axioms for the AND operator, that Z ANDed with 1 produces Z, and Z ANDed with 0 produces 0. So what we do is we create something called a bit mask. Here we have the value, like I said, the X's are don't cares. I want to read what's in position B0. What I'll do to create the bit mask is I'm going to then place zeros everywhere I don't care about what the bit value is. So here my bit mask in B7 through B1. I don't care what those values are. I place a 1 here in position B1, right? Because I'm going to AND this with whatever stored in B0 to then give me then the value of B0. And so I want to drive all these others to 0. So here's my bit mask, this binary pattern. When I use the bitwise operator AND, so value ANDed with bit mask will produce this result. B7 through B1, the result will be zeros. And then if I have a 1 in B0, 1 ANDed with 1 will produce a 1 here. If I have a 0 here, 0 ANDed with 1 will produce a 0. I'll be able to then compare the result, right, of the value ANDed with the bit mask to 0 or 1 to determine the state of B0. Right? And then I've given you a C program where we actually do that. So let's just pop over to code blocks, and let's take a look at this program. Right. So here, the value stored in bit B0, I am using a data type called an unsigned int, so uint 8_key is an unsigned 8-bit integer. This type is very handy because it guarantees that I will have 8 bits that I'm working with here. In order to use that type is found, or it's defined in this library, in this header file, standard int, standard int. We'll have to include that as well. Right, now I've created an array of 2 values. Right, in one I'm storing the hexadecimal 0, so we'll know that all of the bits will be 0. And the other one I'm storing, initializing it with hexadecimal 1. So we know that the rightmost bit will be a 1, all of the other bits will be zeros. Then my bit mask then is this hex 0, 1. Because if we go back to the slide here, let me pop this back up here. This was our bit mask, all zeros and then a 1. So that's a hex 0, 1 for our bit mask. And so here we're going to take the value stored at index I as we go through the loop and it with a bit mask. When that's equal to a 1, we'll know that the value, right, in bit B0 happens to be a 1. Otherwise, if it's not equal to 1, then we'll know that this value is a 0. Let's run the cursor. All right, so we can see here, then in my value array, right, actually this is giving me the character representation. So let's see if we can isolate what's stored at value at index 0, right, and value at index 1. All right, so we've got 0 here and 1 here. And now as we step through, so next I is equal to 0, right? Value at index 0 is this value here. We're going to AND that then with a hex 0, 1. Well, that will give us a value of 0, right? Which means then this comparison is false. It's not equal to 1, so we'll know that bit B0 has a value of 0. Right? We'll see next line, right? That prints out, that tells us bit B0 of the number 0 is a 0. And then we'll loop through this again. We'll set I equal to 1. We'll value at index 1 is this hex 0, 1. Hex 0, 1 ANDed with our bit mask, that's hex 0, 1, will produce a 1. Right, this will be true, and we'll then be able to say that there's a 1 stored in bit B0, right? Which this pops up here, right? Bit B0 of hex 1 is a 1. And of course, if we were to go through, our program would end. And you want to remember then, right, the binary pattern for hex 00 is, right, and when you AND that, right, so if you're going to AND that with your result, then will be all zeros, right? But hex 01 is this. When you AND that with that, you'll get a 1 in position B0 or the number 1, which is why we do this comparison here. And so that's one way then of checking bit position B0. Okay, let's take a look at what happens if we want to check bit position B1. We're still going to use a bit mask, but now bit position B1. We don't care what's in B7 through B2. We don't care about B0. We care about B1. So what we do is, like we said, we put zeros in every place. So our bit mask contains zeros for the ones we don't care to read. For the bit we do care to read, we place a 1. We know that that Boolean axiom, right, if we AND anything with a 1, it's going X AND with 1 will give us whatever stored in X back. So when we AND value with bit mask, right, we'll get zeros in every single position except for the bit that we're wanting to read. If this bit happens to be 0, 0 AND with 1 will give us a 0. This entire result will be 0. We'll then know that bit B1 is a 0. Otherwise, when B1 is a 1, well, we'll have 0, 0, 0, 0, 1, 0, right, which is a 2. So we can compare the result to either 0 or 2 to determine the state of B1, right? When B1 is a 0, the AND result produces zeros, right? When it's a B1 is a 1, the AND result produces then this hex 0, 2, or the number 2, right? And we do that then in example 11. So let's look at example 11 here. Let's close 10. Let's not save that change. And this is still running. Let me stop that. All right, here's our example. Then once again, I'm using this data type of unsigned int. So uint 8_t is an unsigned 8-bit integer. We've got this array here. Right, index 0 will have the value of 0. Index 1 will have the value of 2 stored in it. Our bit mask then, right, is a hex 02. Right, remember we put the 1 in bit position B1, so the hexadecimal representation of this binary string is that hex 02, right, which leads us then to create this bit mask, right, to just simply try and read what's in bit B1. And let's run the cursor. All right. And so we're going to set I equal to 1, like value at index 0 is all zeros, so that then 0 ANDed with 02 is not going to produce 02, it's going to produce a 0. This condition will be false, so we'll print out that bit B1 must be a 0. Right. And then when we AND then this value 2 with a bit mask, which happens to be a 2, that's going to produce a hex 02 result. And this will be true, right? And we simply print out then the bit B1 of 0, right, is a 0. Bit B1 of hex 2 is a 1. And so that's how we read then bit B1. So you should be able to figure out, well, how you would read bit B2, how would you create that bit mask, how would you create a bit mask to read B3, B4, and so on, right? It's the same procedure, it just, the 1s go in the bit position where you want to read, the 0s go everywhere else, and you're going to use the AND operation to simply isolate that bit. Right. Now, there is one other way that we can do this. Let's pop open, then close this down. Let's pop open 12, add this to the project. So 12 does the same thing. What value is stored in bit B1? I'm still using the unsigned 8-bit data types, right? The array is the same, the bit mask is the same. But now another way to do this is I can take then this value, I can AND it with my bit mask here. And when I AND it with a bit mask, so I still want to read what's in B1. So I still need that bit mask of 000, 0010. Right? I still need that. I'm going to AND that together, and then I'm going to shift it to the right one. Well, what happens then, right, when I shift the result to the right? So when we have, say, 0010, and we AND that with 0010, sorry, 10, that produces then the result of 000010, right? We've seen that. And then when we shift that to the right by 1, well, that produces a result of, sorry, this is supposed to be 10. Right, when I AND the same two things together, I get the same result. Shift it to the right by 1, I'm going to get 000001. When I shift this to the right by 1, we're going to get rid of this 0. We're going to put another 0 here on the left, and then we can compare that to 0, or to 1, right? Which will be true then, right? Then. So whenever we have a bit in that position, right, if I shift that over and compare that value to 1, that's another way I can check that. All right, so if we build and run this, we see that we get the same results, right? Bit B1 of 0 is a 0, bit B1 of hex 2 is a 1. So there's two different ways, right? And if we go back here to this example, when we check bit B1, our bit mask was a hex 2. Our bit mask will always be the same. We can take that value, AND it with a bit mask, and compare it to the bit mask. Notice this comparison is the same value as the bit mask. So you could have substituted in bit mask here. Right? Whenever you AND something with a bit mask and compare it back to the bit mask, right, when they're equal, you'll know that you had 1s in those positions. When they're not equal, you'll know that you had 0s in those positions. Otherwise, the other method that you can use is to, same thing, same bit mask, you AND it with a bit mask, but then you shift it to the right. Well, in this case, since I was looking at bit B1, I need to shift it to the right by 1. If I was trying to look for bit B2, I'd shift it to the right by 2. If I was looking for B0, I'd shift to the right by 0. If I was looking for bit B3, I'd shift to the right by 3. Right? So, and then compare to 1, because if I shift all that way over, I should have a 1 in the rightmost position whenever there is a 1 there. Otherwise, I'll have all 0s. So that's another way to tell whether you have 0 or 1. So either one of these methods work. This method happens to be a little, sorry, this method happens to be a little bit more work, which is why I prefer this method. Make the bit mask, and with that, when it's the same as the bit mask, I know I have a 1 in that particular bit position. All right, so that's the end of this lecture then on how to read bits. In the next lecture, we'll talk about how to set bit values to either 0s or 1s.